The last time the Pico volcanic system erupted, it sent rivers of glowing basalt racing across the island's southeastern flank, all the way into the Atlantic Ocean, and the year was 1720. And not a single person alive on Earth today has ever witnessed what this mountain is actually capable of. That was 306 years of silence. 3 centuries of a volcano sitting 2,351 meters above the ocean's surface, holding its breath. And as of April 1st, 2026, deep beneath the Faial-Pico channel, the breath has started moving again. But that is not even the real story, because the tremors recorded in the Faial-Pico channel over the past 3 weeks are not simply the story of one dormant volcano beginning to stir. They are a signal being transmitted along one of the most geologically complex and underappreciated danger zones on the surface of this planet. They are a message written in the language of magma and fractured ocean crust. And that message connects the Azores archipelago to 3 tectonic plates simultaneously, to the longest mountain range on Earth hidden beneath the Atlantic, to a submarine volcanic system that CIVISE, the Azores Seismovolcanic Information and Monitoring Center, has publicly stated can erupt with limited precursory signals. Read that again slowly. Limited precursory signals. In the world of volcanology, that phrase is the equivalent of a fire alarm with no batteries. The monitoring is in place and detection is possible, but prediction is not. And what that means for the 67,000 people living across the central island group of the Azores, across Pico, Faial, São Jorge, Terceira, and Graciosa, is that the margin between watching and running may be measured not in days but in hours or less. To understand why what is happening right now in the Faial-Pico channel is genuinely alarming, you have to understand what the Azores actually are. Because most people picture them as a charming Portuguese archipelago in the middle of the Atlantic, a place of green volcanic hills and thermal springs and hydrangea-lined roads. That image is accurate. It is also like describing Krakatau as a tropical island with nice beaches. The Azores are not simply islands. They are the exposed tips of a structure so vast, so violent, and so continuously active that it makes the Pacific Ring of Fire look geographically predictable. The Azores sit directly at the Azores Triple Junction, the exact point on this planet where 3 of the largest tectonic plates on Earth collide, diverge, and grind against each other simultaneously. The North American plate to the west, the Eurasian plate to the northeast, and the Nubian plate to the southeast. 3 plates, 1 convergence point. And the islands of Pico and Faial are parked directly on top of the boundary between the Eurasian and Nubian plates, in a zone of diffuse deformation so complex that GPS measurements collected by researchers between 2002 and 2017 showed that Pico and Faial are not moving with either plate. They are trapped between them, caught in a zone where the crust is being slowly pulled apart and compressed at the same time, at rates that can accelerate without warning. The Mid-Atlantic Ridge, which separates the Americas from Europe and Africa, spreads at approximately 5 centimeters per year. That is the width of your thumbnail. But in the Azores, that motion does not happen cleanly. It splinters into a web of faults, rifts, and submarine volcanic ridges, and the Pico-Faial volcanic ridge is one of the most active structural zones along that entire web. What does that mean in practical terms? It means the Faial-Pico channel, the 8-kilometer-wide strip of ocean between these 2 islands that most tourists photograph from ferry decks, is not calm water sitting between 2 scenic hills. It is a volcanic battlefield. The floor of that channel contains the remnants of ancient volcanic cones that were active before human civilization existed. It contains the Cachorro submarine volcanic system, a network of seafloor fissures and submarine vents named after the rocky lava coastline on Pico's northwest coast. The coastline where, in a historical record documented by the Smithsonian Global Volcanism Program, previous small submarine eruptions were observed by fishermen, with the Horta observatory seismographs having registered tremor on the days before. The Cachorro system is not a geological curiosity. It is a live volcanic structure that sits directly beneath the channel where the current seismic activity is now being recorded. And as of the week of April 9th, the volcanic alert level for the Faial-Pico channel has been raised to V1 by CIVISE, the second lowest level on an 8-tier scale. But here is where this story becomes genuinely alarming. In the 2022 São Jorge seismic crisis, volcanologists watched the alert climb from V1 to V4, a level described as carrying a real possibility of eruption within days. The scale can move quickly, very quickly. Here's what the data actually shows as of today, April 21st, 2026. Beginning on April 1st, low-magnitude seismic activity was detected offshore the northwest coast of Pico, in an NESW-oriented structural zone stretching from west of Madalena to north of Legido. The earthquakes occurred along a line that follows the architecture of the Cachorro submarine volcanic system, not randomly scattered, but aligned, which tells scientists something critically important. Aligned seismicity suggests movement along a structural feature, a fissure, a conduit, a pathway. The depths range from approximately 20 kilometers down to near surface. 20 kilometers, that is deep enough to be drawing on mantle-influenced magmatic sources, not surface water, not shallow hydrothermal venting. And near surface, some of the events are occurring in the shallowest possible zone, the zone where magma meets ocean water, where the physics of eruption become violently unpredictable. The activity remained slightly above reference levels through the first week, but it did not stop, and it did not decrease. On April 9th, Civisa made the formal decision to raise the alert. That decision is not made casually. It is made when the data pattern crosses thresholds that scientists have established through decades of monitoring across all 9 Azorean islands. The threshold was crossed. The system is not dormant. The system is awake. Now let us talk about what Pico actually is, because the name alone does not prepare you for the scale of this volcano. Pico is the highest mountain in Portugal. It rises to 2,951 meters above sea level, but that number is deceptive because it measures only the part you can see above the ocean. The true base of Pico Volcano sits on the seafloor, far below the surface of the Atlantic. The total height of this volcanic edifice, from its submarine foundation to its summit, is estimated at over 3,500 meters, taller than any peak in continental Europe. It is a basaltic stratovolcano with a 500-meter wide summit crater capped by a steep secondary cone. It is built on top of an older linear volcanic ridge that forms most of the 48-kilometer-long island. And the critical geological fact that scientists at institutions, including the universities of Azores and Lisbon, have documented through high-resolution bathymetric mapping and KR dating is this. Pico Island has experienced 2 major catastrophic flank collapses in the past 130,000 years. The debris from the northern flank collapses accumulated on the floor of the São Jorge Channel. The research has identified over 1,200 submarine slope valleys around the central Azores, mostly caused by landslides. And 13 of those landslide events, according to published geological assessments, would likely have generated tsunamis reaching 1 to 7 meters at the source. This is not speculation. This is documented geology. The evidence is still there on the ocean floor, waiting to be read by anyone with the bathymetric instruments to see it. The people who live closest to what the data shows are the residents of Madalena. Madalena is the main port town on the western end of Pico Island, the closest settlement to the current seismic activity. Around 2,500 people live in Madalena. Their daily life looks like this. Fishing boats leave before dawn. The smell of the ocean is constant. Wine is produced from vineyards planted in dark basaltic soil that locals call carrés, low stone walls separating individual vines from the Atlantic wind. Children walk to school past lava rock walls that were built by hands that had never heard the word volcanology. The ferry to Faial crosses the channel several times a day, taking people to Horta, the main city of Faial, population around 6,600, for shopping, medical appointments, the airport. The channel that ferry crosses is the channel where the earthquake swarm is currently active. The question those people would ask, if they could read a seismogram the way you and I read a headline, is the same question the scientists are asking right now. Is this the system breathing, or is this the system clearing its throat? The historical record provides a deeply uncomfortable answer. In 1718, a fissure eruption broke open on the northern flank of Pico and burned through until August of that year, producing lava flows and scoria. In 1720, just 2 years later, the southeastern flank opened and sent lava into the sea. 2 eruptions within 2 years from different flanks of the same volcanic system. The residents of early 18th century Pico had no seismometers, no GNSS deformation networks, no satellite thermal imaging. They had fire and ash and the sound of the mountain moving. But the most relevant historical comparison is not the Pico eruptions themselves. It is the 1998 Faial earthquake, which struck on July 9th with a magnitude of 5. 8. Faial and Pico are part of the same volcanic ridge, separated by the channel where the current seismicity is occurring. That earthquake caused 8 deaths and left 1,700 people homeless. It hit with almost no usable warning. And before that, the earthquake of January 1st, 1980, magnitude 7. 2, centered in the same central Azores group, killed 61 people, injured more than 400, and caused severe structural damage across Terceira, São Jorge, and Pico. The strongest earthquake ever recorded in the Azores region since 1900 reached 6 magnitude. The geological record in this zone is not a record of minor inconvenience. It is a record of repeated catastrophic events separated by intervals of quiet that people in every generation have mistaken for permanent safety. And here is where the system becomes even more alarming, because the Pico seismic swarm does not exist in isolation. It exists within a planet-wide web of geological stress that is currently active across multiple theaters simultaneously. The Terceira Rift, the major structural system that runs through Graciosa, Terceira, and São Miguel, connecting the central Azores group to the mid-Atlantic ridge axis, is a zone of extensional stress that continuously redistributes forces across all the islands it connects. When one part of that system moves, stress is transferred. This is not a theory. This is the documented mechanical behavior of crustal systems, measured through continuous GPS networks and seismic arrays since at least the year 2000. The 2022 São Jorge seismic crisis. 27,000 small tremors in 2 weeks, alert level reaching V4. GNSS data showing ground inflation that scientists interpreted as evidence of magmatic intrusion occurred just 60 kilometers from where the current Pico-Faial channel activity is now unfolding. Seismologist João Fontiella, commenting on the São Jorge crisis at the time, called the pattern extraordinary. At the time, geologist José Madeira reminded the scientific community that previous eruptions on São Jorge in 1580 and 1808 were accompanied by pyroclastic flows, fast-moving currents of hot gas and volcanic material traveling at 100 kilometers per hour. The 2022 crisis eventually quieted, but it logged over 43,000 low-magnitude events before Civisa reduced the alert level that June. The channel between Pico and Faial shares the same broader tectonic framework as that crisis, the same fissure architecture, the same plate boundary stress field. The second global system that connects directly to this event is solar activity. This connection is contested in some scientific circles and cautiously acknowledged in others, but the data exists, and it deserves to be discussed honestly. Space weather researchers, including those publishing through NOAA and academic institutions, have documented statistical correlations between periods of elevated solar wind pressure, geomagnetic storm activity, and increased rates of seismic and volcanic unrest. The mechanism proposed involves the electromagnetic loading of ionized fluids in the crust, the same hydrothermal systems that occupy volcanic zones, and the possible triggering effect of rapid geomagnetic shifts on piezoelectric stress in crystalline rock structures. The April 2026 period has seen measurable solar activity. The Earth's magnetic field is not static. It is a living system, interacting with the solar wind at speeds measured in kilometers per second. And the Azores region, sitting in the mid-Atlantic at a zone of thin oceanic crust above an active mantle hotspot, is precisely the kind of geological environment where external electromagnetic perturbations could theoretically influence fluid movement in volcanic plumbing systems. Scientists are careful to say, but that careful language carries its own warning, that correlation is not causation, but that the correlations themselves are real enough to study, real enough to include in hazard assessment frameworks, and real enough that dismissing them entirely would be scientifically premature. What the data actually shows is a convergence, a seismic swarm in the Faial-Pico channel, aligned along a known submarine volcanic system, with earthquake depths reaching from 20 kilometers to the near surface, continuing for 3 weeks, strong enough to be felt locally at low intensity by residents of Madalena and Horta, triggering a formal volcanic alert level change by Civisay on April 9th. A submarine volcanic environment where, by Civisay's own published statement, eruptive activity can occur with limited precursory signals, a historically proven system that last erupted in 1720 that has produced 2 major catastrophic flank collapses in the past 130,000 years, that shares its structural framework with a tectonic boundary zone where the deadliest Azorean earthquake in recorded history, magnitude 7, 4, occurring in 1787, killing over 1,000 people, originated near São Jorge's north coast. A mid-Atlantic setting where submarine eruptions have occurred within living memory, where lava balloons rising through the ocean surface from submarine fissures at depths of 400 meters were photographed and documented by scientists at the Azores Volcanology Center as recently as the 1999-2000 Serreta submarine eruption off Terceira. This is not a theory. This is not alarmism. This is the documented geological identity of this place, and the people living in its shadow deserve to understand it clearly. Think about Horta. Horta, the main city of Faial, sits on the edge of the channel. About 6,600 people wake up there every morning, look across the water and see Mount Pico rising on the horizon, a perfect volcanic cone, the kind that painters choose because the geometry is almost too beautiful to be real. Sailors from every ocean call Horta's marina a second home. It is one of the most famous transatlantic waypoints in the world. The harbor walls there are covered in painted murals left by every yacht crew that has ever stopped. A tradition of marking passage that stretches back decades. What those sailors see when they look east at Pico is one of the most strikingly formed volcanoes on the planet. What the instruments beneath their feet are now recording is something that the 18th century residents of this island group were never given the luxury of knowing in advance. The question those 6,600 people in Horta would ask, if they could read the seismogram of the past 3 weeks in real time, is how much warning will we actually get? Civisa's 8-level volcanic alert scale runs from V0 to V7. The system is currently at V1. V1 is defined as a metastable equilibrium phase with weak activity above reference levels, activity that may be of tectonic, hydrothermal, or magmatic origin. That word, magmatic, is the word that separates a geological footnote from a genuine emergency. At this moment, Civisay has not confirmed a magmatic signature. The earthquakes could be tectonic adjustments along the Turkera Rift, stress redistribution from the plate boundary zone, hydrothermal fluid movement through the submarine system. Scientists do not yet know, and that uncertainty is not a reassurance. It is the condition itself. Because in submarine volcanic environments, the window between the first magmatic signal and the onset of an eruption can be extraordinarily short. The 1957-1958 Capelinos eruption on Faial, the most recent subaerial volcanic event in the Azores, which created an entirely new peninsula on Faial's western tip and changed the island's shape permanently, began offshore as a submarine eruption that escalated rapidly. The lighthouse at Capelinos, whose ruins still stand as a monument to that event, was eventually buried under meters of volcanic material. Before it was buried, the keepers of that lighthouse watched the sea boil. The question is not whether. The question is when, and more precisely, the question is whether the when is measured in centuries or years, whether the current activity is the system settling back into its long silence, or the first sentence of a much longer statement. What makes a definitive answer impossible is the nature of submarine volcanic systems themselves. On land, volcanologists can deploy seismometers, tilt meters, gas sensors, infrared cameras directly on the volcanic edifice. They can watch the mountain breathe. In a submarine environment, the monitoring is more distant, more diffuse, more dependent on indirect signals. The Azores seismological network comprises nearly 40 short-period and broadband seismic stations distributed across the islands. Portable arrays are deployed during crises. GNSS deformation networks track crustal movement in near real time. Satellite platforms, including Copernicus Sentinel-2, whose image acquired on April 14th showed the active seismic zone in the Faial-Pico channel, provide thermal and visual monitoring from orbit. The infrastructure is real. The commitment of SciVSA, the Volcanology Center of the Azores, and their partners at the Smithsonian Global Volcanism Program, and the USGS is real. But the instruments measure what has already happened. Prediction, true prediction, the kind that tells you a submarine eruption will begin on a specific day at a specific location, remains beyond the current state of the science. Minutes are not hours. Hours are not days. And in a submarine volcanic environment, the signal that matters most may arrive with less time to act on it than anyone wants to acknowledge. There is one more layer to this story, and it is the layer that sits beneath all the others, literally and figuratively. The Pico Fayal volcanic ridge, as documented in research published by scientists including Ana Costa, Fernando Marquez, and Alberto Hildenbrand, has experienced at least 2 major catastrophic flank collapses in the past 130,000 years. The northern flank of Pico shows 2 conspicuous arcuate-shaped depressions on high-resolution digital elevation models, the geological scars of ancient mass-wasting events that sent enormous volumes of basaltic material into the São Jorge Channel. The submarine debris fields from those collapses are still there on the ocean floor. The research team, analyzing more than 1,200 submarine slope valleys in the central Azores, identified 13 landslide scenarios that would generate tsunamis with wave heights of 1 to 7 meters at the source. For comparison, the Indian Ocean tsunami of 2004 generated waves of similar heights at source points before traveling across open ocean and reaching 30 meters as they compressed against coastlines. The Azores are not in the middle of nowhere. They are in the mid-Atlantic, a geographic position from which a tsunami could reach the coast of Portugal in approximately 2 hours, the Canary Islands in under 3 hours, and the eastern coast of North America in 6 to 8 hours. The 1755 Lisbon earthquake, which generated a tsunami that reached Portugal in under an hour and killed an estimated 60,000 people, originated from the Azores-Gibraltar fracture zone, the same tectonic system whose eastern terminus connects directly to the Azores Triple Junction where Pico sits today. This is not a theoretical cascade. This is a cascade that has already run its course once in documented history, with a verified death toll and a verified mechanism. The geological conditions that produced the 1755 event are still present. The stress field is still loaded. The plates are still moving. The 15,000 people who live on Pico Island, in the towns of Madalena, Lajes do Pico, São Roque do Pico, and the dozens of small villages that stretch along the island's volcanic spine, live in a landscape of extraordinary beauty that is also an archive of catastrophe. The basaltic soil that makes their vineyards among the most extraordinary in the world is the product of eruptions that burn through the same ground their houses stand on. The lava delta coastlines where children swim in summer were formed when liquid rock met the ocean. The curving depressions on the island's northern slopes, visible in satellite imagery if you know what you are looking for, are the ancient scars of collapses large enough to have reshaped the entire island. These people do not live in ignorance. They live in an archipelago with a robust civil protection system, with SciVSA monitoring every tremor, with emergency protocols tested during the 2022 São Jorge crisis, with evacuation routes and community awareness built over generations of coexistence with a geologically restless landscape. But coexistence is not immunity. Preparedness is not prediction. And the message being transmitted right now from 20 kilometers beneath the Faial-Pico channel, aligned along the Cachorro submarine volcanic system, consistent in its NESW orientation, maintaining its elevated frequency for more than 3 weeks as of this morning, is a message that the instruments are recording, that the scientists are analyzing, that CIVISE is monitoring around the clock, and that the 8-level alert scale has formally recognized. The system is not dormant. The system is speaking. What it is saying is not yet fully understood. That is the honest truth that sits at the center of all the data and all the monitoring and all the centuries of geological record. The 40 seismometers distributed across the Azores can tell you where the earthquakes are. The GNSS networks can tell you if the ground is inflating. The Sentinel-2 satellite can look down at the ocean surface for thermal anomalies. But the magma itself, if there is magma involved, sits in a zone of the Earth's crust where no instrument has ever been placed, moving through pathways carved over hundreds of thousands of years, obeying dynamics that the best volcanological models in the world can describe in general terms, but cannot predict in specific ones. The Pico volcanic system last erupted in 1720. Before that, 1718. Before that, 1562, when lava flows reached the northern coast. The eruption recurrence interval for this system is not millions of years. It is not even thousands. In historical time alone, the past 5 centuries of recorded observation, Pico has erupted at least 3 times from different parts of its flanks. The offshore Cachorro system adds additional eruption history that extends before written records. The system has erupted. It will erupt again. The monitoring is in place. The detection is possible. The prediction is not. And so what the people of Madalena have this morning, what the sailors in Horta's marina have, what the fishermen heading out before dawn from Lajes do Pico have, is the same thing that every generation before them has had. A mountain of extraordinary scale and documented violence. A channel whose floor carries the architecture of submarine eruptions and ancient collapses. A plate boundary that has not stopped moving since long before the first human being ever set foot on these islands, and instruments that can tell them when something has already changed, but cannot tell them when the change becomes something else entirely. The alert is at V1. The seismicity is above reference levels. The Cachorro submarine volcanic system is the locus of the activity. And somewhere beneath the dark water of the Faial-Pico channel, at depths ranging from 20 kilometers to the near surface, the Earth is moving in ways that every seismometer on the island can hear, but no scientist can yet fully translate. 306 years since the last eruption. 3 weeks since the current swarm began. 20 kilometers to near surface depth range. 8 alert levels on the CVSA scale, currently at the second lowest. 40 monitoring stations listening to the ground. 15,000 people on Pico Island. 6,600 in Horta. An ocean that has swallowed the evidence of 2 catastrophic collapses and still shows the scars on its floor. A submarine volcanic system that, in the agency's own language, can begin erupting with limited precursory signals. The question is not whether the Pico system will erupt again. Every geologist, every volcanologist, every seismologist who has studied this system agrees on that. The question has never been whether. It has only ever been when. And whether, when the answer to that question finally arrives, it arrives with enough warning to matter.